Given JI is parallel to KH, so U and U, they're parallel. Great. I need to prove that JGI is similar to KGH. Now, that shape means similar. Similar is different from congruent. Congruent mean they were exactly the same, exactly. Similar means they're the same shape. It's just one's bigger than the other. And there's three proofs or three theorems that we use for this. A means if I could show that two angles are exactly the same, then I have myself similar triangles. And if you're like, why not the third angle? Because if you can show that two angles are the same, then the third angle is going to automatically be the same. Another one is SSS. And you might be thinking, isn't that a congruency one? Yes, it is. But what we're talking about here is ratios. So if I have a triangle with sides A, B, and C, and if I could show that it's congruent, or if the ratio is congruent to sides D, E, and F, then I have myself SSS. The third one is SAS. So if I could show that two sides are proportional, and if I could show that two angles are congruent, then I'm good. So what I'm going to do here is see what I have, see what information I have. I have the fact that JI and KH are parallel. Now that would make J and K congruent because they're corresponding angles. What that also means is H and I are congruent because those are corresponding angles too. So right then and there, I have my double A. Okay, and I can prove that these two guys are similar. So not a lot to show. In fact, this might be only 3 steps, but sometimes with these similar ones, you're not going to show a lot of steps. The similar proofs are a whole lot friendlier than the congruent proofs. So let's start out by saying my given that JI is parallel to KH, and that's my given. That means that the measure of angle GKH is equal to the measure of angle GJI. Also, the measure of angle GHK is equal to the measure of GIJ. G.I. Jane? Nope, close. G.I.J. Ooh, don't make a G.I. Jane joke around Will Smith. He'll slap you. Because of the Oscars. Why is that? That is the definition of corresponding angles. Now, if you have a really mean teacher that doesn't accept double A, which is ridiculous, and they force you to do triple A, AAA, then the third angle would be G is congruent to G using the reflexive property. But like I said, we don't need that because we only need 2 angles are the same. And so since 2 angles are the same, we have enough information to say that triangle JGI is similar to triangle KGH. And that is using the double A theorem. Okay? So again, similar proofs are a lot friendlier. They usually take less steps. But we're done. That's how I did it. Given MQ is parallel to OP, so MQ, OP, I need to prove that MNQ is similar to PON. This is similar. Remember, similar is not congruent. It can be, but it's not. Okay, so with congruent, we had like SSS, SAS, ASA, AAS, HL, HA, LL, LA, and you're like, well, which one should I use? Not so many. See, with similarity, we only have 3 ones that we need to worry about. Showing 2 angles are congruent, or we could show that the sides are proportional, which means you have 3 fractions equaling each other, or you can show that 2 sides are equaling each other as far as proportion goes, and 2 angles are equaling each other. Now, let's see what I can do here. I have the fact that these guys are parallel. Since they're parallel, I can say that you guys are alternate interior angles, so you're the same. And let's mix it up, because I already did one where I did... No, I didn't. I take it back. Let's just do this. I was going to do vertical angles, but I changed my mind mid-sentence. So because these are parallel, these alternate interior angles are going to be congruent, and these alternate interior angles are going to be congruent. If you wanted to be like, well, sir, I wanted to do these alternate interior angles and vertical angles, will that work? Sure will, because that follows AA. I'm not giving really a whole lot of information about my side, so I'm not going to bother with these guys right here. I'm sticking with AA. So what I'm going to do is I'm going to state my given. I'm going to say that these 2 guys are congruent by definition of alternate interior angles, and then my last step 3, I could say that they're similar using AA. So number 1 is the given. Side MQ is congruent to side OP, and that's my given. Let's use the right colors. 2, I could say that angle QMP, the measure of angle QMP, is equal to the measure of angle OPM. Also, the measure of MQO is equal to the measure of POQ. And again, my reasoning for that was the definition of alternate interior angles. Oh, these angles are the same? These angles are the same? And all I have to do is prove that they're similar? Then they're similar. M and Q is similar to PON. And that's using AA. And that's it. Given AB over DE equals BC over EF equals AC over DF, I need to prove that these 2 guys are similar. All right, well, there's 3 ways that you can prove that triangles are similar. Okay, you could use the angle-angle method. If you could show that 2 angles are congruent and 2 more angles are congruent, I could use the angle-angle method. I could also use the SAS method. The SAS method says that if you could show that 2 sides are proportional to each other, side over side equals side over side, and if you could show that 2 angles are congruent, then you have SAS. The third option is SSS. And SSS, or if you're a snake, says that if you have a side over a side, corresponding sides, equals a corresponding side equals a corresponding side, then you have similar triangles. And you might look at this and say, doesn't the given tell you pretty much the same thing as this? And I would look at that and say, why, yes. Why, yes, it does. And if you're thinking, so this proof is state your given and then state your proof, and it's only a 2-stepper? Yes. Yes, it is. Similarity proofs are not that bad compared to congruent proofs, and this is one of them. This is a 2-step proof. That was supposed to be a circle over 1. AB over DE equals BC over EF equals AC over DF given. Oh, look, these proportions equal that proportion, and we're done. ABC is similar to DEF. And that's using SSS. Very, very, very basic. Very, very, very easy. That's it. We're done. Given angle A is congruent to angle B, all right, they correspond maybe. I need to prove that ABE, this whole thing, is congruent to BCD. All right, so there's 3 congruency proofs. Given angle A is congruent to angle B, so these guys, I need to prove that AB is similar to BCD. So similar is a lot friendlier than congruent. Similar, I have 3 main theorems that I can use. If I could show 2 angles are congruent, I'm done. If I could show that 2 sides are proportional, so if I say that side over that side is equal that side over that side, and if I show that 2 angles are congruent, I'm done. Or I could show that that side over that side equals that side over that side equals that side over that side, and then I'm done. I look at this and I see an angle already. So my thinking is, can I do a whole lot with the sides? No. But you know what else I can do? I could show that angle C is congruent to itself using the reflexive property. So if angle C is congruent to itself, and if I have 2 angles already, it's AA. For some reason, I didn't copy and paste the statements and the reasons 2-column proof thingy, so I'm going to do that right now. Statements, reasons. And what I'm going to do is I'm going to state my given. I'm going to say that the measure of angle C is the same as the measure of angle C. And then that's it. That's all I need. And then by AA, these 2 guys are similar. So statement number 1, the measure of angle A is congruent to angle B. Given. 2, let me get the right colors. I could say the measure of angle C is congruent to the measure of angle C, and that's the reflexive property. Anytime you say something is equal to itself, that's the reflexive property. Now that I have these 2 angles and these triangles are the same, and this angle is exactly itself, that's angle. I've done enough. Okay, triangle Abe, rest in peace, Prime Minister of Japan, is similar. Ooh. In being reverential to the deceased, I accidentally screwed that up. ABE is congruent, similar to BCD, and I used AA. Or as the Fonz would say, A. From Happy Days. It's a show from like the 70s, I believe. Took us back to when things were happy. Like and subscribe.